Hey guys, Professor Anwaar back here for another video, and inside this video I'm going to be talking about a topic which I see a lot of people struggle with in chemistry. So, the law of conservation of mass is a law which basically states that mass is equal to mass. So, the products of the total mass will always equal the same as the reactants. But before we get to that, let's talk about balancing equations. Well, the law of conservation of mass has a huge part in balancing equations because that's the reason we do it. There's no point for us to add a 2 beside lithium, for example, just to balance it if there's no point. Why can't we just leave lithium unequal on one side and then equal on the other? Well, that's the reason we do it. It's because of law of conservation of mass. We have to do the total reactants mass is equal to the total products mass. So let me give you guys an example of how balancing equations work. So let's have the diatomic equation. Let's do one of the most famous chemistry equations. Let's do water. So we have two diatomics. Well, we have hydrogen as one. We know that that's a diatomic. Um, then we have oxygen, which is a diatomic, and then well, what do we have? Well, we have hydrogen and oxygen, and then what do we have? We have water. This is, you guys might be wondering, well, let me wonder, well, there's hydrogen, there's oxygen, and there's water. Well, let's just look over the different types of atoms. Well, one of the big clues which you guys can see that this equation's not balanced is that there's not equal amount of oxygen. So if we do hydrogen equals to 2, we have oxygen equals to 2, then we have equal signs here represent the equation, and then we have hydrogen equals, or sorry, that's a very bad H. Um, we have hydrogen equals to 2, and then we have oxygen equals to 1. Well, this doesn't seem to add up. Well, if law of conservation of mass says that equal products must equal the total reactants, well, this is not equal because oxygen is not equal, and oxygen is not equal here. So let's get rid of the product side first. So let's rewrite this. Well, what can we do? Well, all that we have to make oxygen is we have to add another oxygen. So let's just multiply it by 2. So let's add a coefficient of 2. So let's do H2. Oh, so what does that make? Well, it makes the 2 into a 4, so now we have 4 hydrogens, and this turns this 1 into a 2, so now we have 4 hydrogens, we have 2 oxygen on the right side. Well, the oxygens are correct now, but the hydrogens are not correct. Well, let's just do the same thing we done on the left side. Well, rather than multiply the entire equation, let's just multiply the diatomic of hydrogen. Well, now, this is going to make this into 4. Let's do a checklist. Well, we have 4 hydrogens here, we have 4 hydrogens here, we have 2 oxygens here, we have 2 oxygens here. And that's how you guys get your full marks on balancing equations, but you guys might be thinking that's way too easy. It's a synthesis equation, there's nothing difficult about it, and it's very easy. So, let's try a much harder one. So, let's use one which does not necessarily fall into the category of ionic bonds or easy. Let's do a much more difficult one. So, let's do this equation. It's one of the most famous equations, if you guys ever go into, like, biochemistry. So it'll be an equation which you'll see a lot. So, let's do iron, and then let's do oxygen. Just give me 1 second. So, you guys might be looking at this, and you guys might be seeing that we've never seen an equation like that. And you guys are actually right. You most likely, most of you have not seen an equation which, deals with 3 and then 4. It's quite unrare to see it at a high school chemistry level, but it's possible. So let's balance this. let's have fun with it. So, what do we do first? Well, the first part what we're gonna do is look at the much more simpler part. Let's just do counting. How about that, guys? Let's just count. So, what do we have? Well, if you guys don't realize, this arrow is representing the equal sign which we used before. So this arrow is simply saying that the reaction is occurring and then this is going to be the final. That's all it's saying. There's no difference between this and the equal sign, but more preferably in chemistry, the arrow sign is used just to show that the chemical reaction has taken place. So let's just count. Well, we have three irons, and then let's do that. Well, we have 5 oxygens because we have CO. So, oh, sorry, I wrote iron instead of 3. My bad. And, let's do oxygen. Well, that equals to 5. And, carbon, which equals to 1. And let's do the right side. Well, Fe equals to, Fe equals to 1. C equals to 1, and then O equals to 2. You guys automatically see that this is not balanced. And there's a reason for that, because firstly, the main indicator is that oxygens are not balanced. There's 2 and 5, and the carbons are balanced, but the irons are not either. So, what do we do first, you guys might be wondering? Well, let's try to get the oxygens balanced first. So, how do we do that? Well, let's do this first. So let's do the easiest side, because it's always much easier working backwards rather than working forwards. So, let's get rid of this product side, and let's rewrite it again. Let's use the coefficient, for example. Let's use 3. Let's use 3. It's a very good coefficient, and if we use 3, we'll get 6 oxygens on the right side, and then it'll be much closer to 5 than 2. So let's just do that. So we would have Fe plus 3CO2. So now let's get rid of these bottom 2 numbers, because those are now incorrect. So what do we have now? Well, we have 3 and we have 6. So now what do we have? Well, nothing's still balanced. But let's continue. How about we do that? So let's do this. Well, let's add 2 here, for example. Let's see what that does. Well, now we're gonna have let's just get rid of that. Now we're gonna have 2, and then now we're gonna have 6 over here. So now we have the oxygens balanced, but we have the carbon somewhat balanced. It's still 1 away. It's not equal, and we have iron not even close to being balanced. It's still 3 and 1. So let's keep continuing, and then let's get rid of this, for example. So let's get rid of this 3, because I feel like because you guys might be realizing it as well. 3 is causing a problem. So let's get rid of that. Let's get this. Let's get rid of that. And let's put that as a 4. Now let's do the entire process again. Let's just count again. Well, we have 4 carbons. How many oxygen? Well, we have 4 times 1, so that's 4. Then we have 8. Right? So then, oh, I forgot to write down. My bad. 8 and then 3. Then what do we have over here? Well, we have 1, 2, and 1 again. So now what do we have balanced? Well, We have 4, and we have 1, which is not close, but we have 8 and 2. If you guys realize that 4 and 1 have a similarity, so we have times by 4 times by 4. This gives us a clue, guys. Now we have to realize that if we multiply one side by 4 and we're getting close, let's do the same thing over here. Now let's redo it again. Let's get rid of all these numbers over here, and let's see that's what happens. For C, so let's do 4 times 1. Well, that's, of course, 4. And then we have to do 4 times 2. So, well, that's 8. So now we have 8 oxygens. Well, we have this right. We have this right. We have this right. We have this right. Well, we're still missing one thing. If you guys are able to find out this one, it's going to be quite good. I'll let you guys just think about what the final process is to get the iron balanced, and I'll give you guys 10 seconds to do it. You guys can pause the video right now and just think about it. So, to balance the final part of this equation, all you have to do is add a coefficient of 3 here. And now let's think about it. Well, we have 3, and now we have 3, so that's balanced. Well, we have 8, so that's balanced, and that's balanced, and that's balanced, and that's balanced. Well, guess we're all great, right, guys? Well, not necessarily. Now we still have to add the actual states of matter. So, when we're adding states of matter, we use liquid, gas, solid, and aqueous. So, aqueous is pretty much just a solution. If you guys can just remember that, it's just pretty much just solutions. If you guys see something which does not look like a liquid or a solid, but it's a mixture and it looks like a solution, it's an aqueous. So let's just think about this. Um, in this equation, you necessarily don't need to add the states of matter, but in generally with balancing equation, it's always preferred. So let's just think about it. What can we do for the states of matter? Which parts are solids, which parts are gases, and which parts are actually liquids? I'm going to give you guys a hint that I'm not going to do this part for you. I'm going to let you, the viewers, decide the states of matter. And I'm going to see if you guys can actually get it correctly. So let me just remind you of one thing with states of matter, that when you're doing it, just remember that solids, which are generally metals, are written with an S, and then gases, which are generally non-metals, mostly usually around noble gas level, is generally written with the G. Carbon dioxide. Well, carbon dioxide, it's actually right now just carbon monoxide, but carbon monoxide, oxygen, it's generally going to be a mixture, but what is it generally going to be? What state of matter do you guys think carbon monoxide is actually going to be? Is it a liquid? Is it a solid? Is it a well? Is it a gas? And then CO2, and then iron. So iron 3, which iron with substrate 3, I'm going to give you guys as a solid. Oxygen 4 is a gas. So the final parts, I think I've given you guys enough time. So carbon monoxide, generally, especially in this type of reaction, if you guys ever find oxygen with iron, most likely oxygen is going to be paired up with carbon if this is the type of reaction it's given, because carbon and oxygen, which usually creates an oxidation, usually reacts with iron. So it will generally most likely be a gas. This will most likely be a solid, and this will most likely be a gas. So yeah, but if we're doing a much simpler, uh, much simpler way of explaining states of matter, we could simply do something like NaCl. So sodium chloride, well, think about sodium chloride. We have a solid, and we have chlorine. chlorine is an element which can be in multiple states form. It can be in a liquid, and it can also be a solid. But when it's reacting with sodium, which is generally in a solid form or a powder form, it's going to be a solid. Hydrogen, which is generally in a gas form because it's a diatomic, though that's going to be a gas, as to liquid, so like water, for example, or any type of soft drink, which generally has also an chemical equation, well, that's going to be a liquid. And then an aqueous solution could pretty much just be a just a solution. So, like, let's say, for example, um, NaCl with water. Well, that could also be a solution. So let's say NaCl reacted with water, but we're not having the water, so we just have the NaCl. We could write that as a aqueous. I hope I explained balancing equations, the process when you're balancing equation, and how to write the different states of matter. Just remember that matter you always have to do it when you're balancing equations. So you always have to do an S for us if there's a solid present in the chemical equation. If there's a liquid, then it would be an L. If it's a gas, then it would be G. And if it's an aqueous solution, it will be an AQ. Hoped I've explained bounce equation, and I've hoped I've helped someone at least understand when you're doing bounce equation, the different process and how to do it. I would say the ultimate best way to be less confused, guys, is do this method. I did it very slowly for you guys when I was balancing this equation. It's not a hard equation to balance if you've mastered balancing equations, but if you can simply just remember that what elements go where, how elements change when you add different coefficients. If you guys are able to do that in your head, I would encourage don't do this. It's not going to be that helpful for you, but if you're still new into balanced equations, I would highly recommend this. With that saying, guys, Professor Anwar is going to leave now, and I hope you guys enjoyed the video. Thank you for watching.